Hi friends, this is Ganesh. Welcome to my channel. Today I am going to discuss about what is the difference between microprocessor and FPGA with simple example. Before going to the differences, I want to explain few basic points. We all know that one computer. Computer contains input device units, output units, and central processing unit (CPU) and storage unit. In fourth generation computer, this CPU is designed with this CPU is designed with micro size transistor. This CPU is designed with micro size transistor, and that CPU is called as microprocessor, because micro means size of the transistor and processor means this is central processing unit. And the system which contains microprocessor is called as computer. The system which contains microprocessor as a CPU is called as microcomputer. Next, we will see about FPGA architecture. Mainly, FPGA architecture contains three components. First one is programmable logic block, which was indicated with brown color, and another one is interconnections with blue color and IO cells. And these programmable logic blocks we can program as per our requirement. Let us discuss the first difference between microprocessor and FPGA. Okay, microprocessor is a software based one, and whereas the FPGA is not software based one, it is firmware. Okay, what is meant by software and what is meant by firmware? In next slide we will discuss. Okay, what is meant by software? Software means execution of instructions sequentially one at a time. Okay, it requires some operating system to execute that one. Okay, let us take one example to clearly understand, for clear understanding. Okay, now first let us take this example: move a comma b, move c comma a, and halt. Okay, move a comma b means what? The content present in b will be copied to a register. Okay, content present in b will be copied to a register means what? For whom we are saying this one? Content present in b copy to a register, we are saying to the operating system, OS. Okay, we have for operating system we are saying that the content present in b copied to a register. And same way here also, move c comma a, the content present in a will be copied to c. For whom we are sending this instruction? We are sending to the operating system to do like this. Okay, means microprocessor is a software based system. Okay, the it will execute the sequence instruction sequentially one by one, and these instructions are we are sending to operating system to do like this. Okay, next we will see about FPGA. Okay, whereas FPGA is not software based one and it does not have any operating system. FPGA is not software based one and it does not have any operating system. It is a firmware based one. Okay, FPGA, actually FPGA, we will write programs for FPGA is VHDL and Verilog HDL. HDL means hardware descriptive language. Here we will describe the hardware in the form of code. Okay, let us take our example, one example. Now I want to describe the hardware of half adder. Now for describing this one, what I required? What is the relation between inputs and output? Okay, now what is the relation between an input AB and output sum? Is nothing but XOR. Okay, that XOR thing we are writing here. And again, what is the relation between input AB and carry? That one is AND. Okay, that things I am describing here. Means the firmware means nothing but firmware will describes the hardware circuit. Okay, the firmware will describes the hardware circuit. Now it is a not software bus. The software one means here we are not sending instructions to any OS to do like this. Here we are describing our hardware to be like that. Okay. Okay, let us take one more example. Okay, I'm giving one task to microprocessor. When this switch is on, when this switch is closed, that LED must on. Okay, for this task, what microprocessor will do means that microprocessor means OS operating system will continuously observe this switch. Continuously, it will observe this switch, and when this switch is closed, then this LED will be on. That whole operating system will examine this switch, and when this switch is closed, then this LED will be on. Okay, this is the behavior of microprocessor. Okay, the same task if I given to FPGA. Okay, same task I have given to FPG. What it will do? Simply this one. Okay, it will make one schematic. Okay, that schematic is not good. When this switch is closed, okay, you will get logic 0. If logic 0 is coming after inverter, it is logic 1, and logic 1 and here it is 0. What is the thing? It will on. Means this whole logic will be converted into hardware, on hardware, simple hardware. If you take this one, he in the microprocessor, continuously microprocessor OS will continuously examine the switch, and then when the switch is closed, then it will send logic 1 to this one. But here FPGA, when FPGA is given one hardware, directly provides one hardware which will make when the switch is closed, it will get logic 0. When logic 0 is coming, inverter will provide logic 1, and that logic 1 will on the system. Means whole FPGA is not required. Only one inverter is sufficient for this application. That is the major difference between microprocessor and FPGA. Microprocessor continuously, that in a group of instruction will be executed continuously, and it will examine the switch continuously. But whereas in FPGA, it's not like that. Okay, for that logic, it will define one logical circuit. For that logical circuit, will define the your task. One more difference is microprocessor is a non-volatile device and FPGA is a volatile device. Okay, what is meant by volatile and non-volatile? We already know. Non-volatile means even if you switch off the microprocessor, the program will be stored in microprocessor itself. But whereas in FPGA, if you switch off that my FPGA, then that program will be lost. But nowadays, FPGA also contains it becoming non-volatile. Means you have to store that program into the flash memory, which is additionally added to this architecture. Let us see the summary of this video lecture. Okay, microprocessor is a software one, and whereas FPGA is not software one, it is a firmware. And microprocessor contains operating system OS, whereas in FPGA operating system is not existed. Here programmable logic blocks and IO blocks etc. are available. Whereas in microprocessor we will write our program in machine level language, assembly level language, high level language. Okay, we already studied in microprocessor subject that. And whereas in FPGA we will write the we will prefer the HDL and VHDL language. HDL means hardware descriptive language. And if you come to microprocessor language will describes the will provide the instructions to OS to do our task. But here we will mention the hardware. Here in this language we will mention describes the hardware which will perform our task. Yeah, microprocessor is a non-volatile device, and this one is FPGA is a volatile device. But if you want to make that store that program, you can store in flash memories which are available with FPGA nowadays. FPGA in one FPGA we can develop multiple microprocessor. That depends on the FPGA what you have chosen. Okay, in one FPGA you can develop two or three microprocessors. Okay, you can design that one in F1 FPGA. Okay, that is the one of the advantage of FPGA. Even not only microprocessor, you can design DSP processor also. Okay, and one more thing is that it is very efficient than microprocessor and it is faster than microprocessor. Now previous example only we have seen which one is the faster. Our FPGA is the faster one. Okay, in next video lecture I will explain each blocks present in FPGA in detail. In my next lecture I will explain the FPGA each blocks in detail. Thank you.